Programming Throwdown, episode 101, ReactJS with Guillermo Rausch. Take it away, Jason.
Hey everybody, we are here with the CEO of Vercel and a co-creator of Next.js, Guillermo Rausch. How are you doing today?
Excellent. Thanks for having me.
Cool. Thanks for being here. So I think this is super interesting. One thing I've talked a lot about on the show is for people who want to just getting into coding, try to build something where you can interact with it, and even better, something where other people can interact with it. That's the way. The hardest part about getting into coding, this is true if you're listening and you're a high school student, college student, or if you're coming to this from another profession, is just keeping motivated, right? And the best way to stay motivated is to have something you can show someone. And really the best way to do that is with the web. It's, as someone who's rolled out, desktop apps, I can tell you it's a huge nightmare. A little bit easier on mobile, not that much. But on the web, it's beautiful. You can just, reserve some space on AWS. If you're a student, it's free. Put your site there and other people can interact with it right away. And so, we're here with Guillermo Rausch, who is the creator of Next.js, which is a platform for basically making that whole process, more beautiful and streamlined. And so I think, I think it'd be great for the audience to just kind of get a bit of background on, if someone comes to you not knowing anything about how front-end dev works, how kind of can you sort of wrap that up for them?
Yeah, so that's a good start. Front end and back end are kind of the two divisions that we typically make when you think about how a website works, right? Like front end being the part that your visitors and your users interact with, and back end being the systems that support that front end, that are typically more related to reading and writing from databases, talking to other services, talking to other APIs, etc. Next.js is primarily concerned with the front end, and React is primarily concerned with the front end. The big thing about React is when we used to make websites in the past, we didn't have good ways of kind of organizing them, kind of having the abstractions for making them work in ways that were very cohesive. So React came out of Facebook open source with this idea of websites and web applications are actually made out of components. That is, to me, the big breakthrough that React has really come up with. It's this idea that I've called it in the past Lego blocks for adults.
All right.
Because as you were saying, like when you're starting to create something new, you need building blocks, right? And when you think about front-end development, the building block that has emerged with the rise of React is a component. So anything that you can, it's funny, like the metaphor, like anything you can build with Legos, right? Like you've seen people build all kinds of things, right? From sticking two blocks together to, building amazing machines. And I think of it that way with React as well, because if you're just new to programming, you can, build a blog. So before we started the call, I was telling you that when we tell people about learning to make a website with Next.js, we point them to nextjs.org/learn, and that walks you through creating a blog. And that blog is built with React components. But with our technology, what we've seen is that people have really built anything you could imagine. So like Hulu.com, their entire marketing website, but also their viewer for, when you're watching a show on Hulu online, it's all built with Next.js and React components. So
that's really awesome.
It's an incredible technology for just organizing this universe that is a front-end development workflow.
Yeah, and one thing that people might not know, my son's been getting really into Lego, and so I've been watching a lot of Lego videos with him. And when they build these huge Lego structures, like if you go to the theme park, right, and there's these enormous Lego, like refrigerator-sized Lego things, is that they actually have something similar. They have this module structure, which is, a group of Legos, and they have people kind of just assembling these sort of building blocks. And they have other people taking these larger Lego pieces, these modules, and sticking them together. Usually it's not just done one Lego at a time. And so what you're saying is that
It's
React and Next let you do that for the web.
Yeah, it really is a good metaphor because what you're describing is effectively what happens when Next.js developers are building really large things, right? Like I use Next.js also for my own blog, and obviously I just work on it myself. I write about different things. I include components sometimes that are more interactive or sophisticated. Like recently I wrote about code golfing, and I embedded a code golf demo. So that's like a really nice property of the web, how
What is Code Golf? I never heard of this.
so code golfing is basically a competition that happens between developers on who can accomplish a certain outcome or a certain output, usually with the fewest number of characters. And since we were on the subject of learning to code, I wrote this blog post about why code golfing is so great, or in general, like little fun competitions are such a great way of learning to code. And there was this website that I point out called code-golf.io that basically has this remote verification system to make sure that you give them your program with very few characters and they ascertain that you're getting to the right output. And just like golf, you're doing so with the fewest number of strokes, right?
Oh, that's cool. Oh, now I get the metaphor. That's awesome.
Yeah. So I wrote about it, and yeah, like I said, like my blog is just not many components, and it's for the purpose of just putting some content online, right? But when I think about the teams that we support at larger enterprises, they are doing exactly what you described. They sometimes have what we call the design systems team, where their whole point is to build this, not just now Lego bricks, but you could think of it like stacked Lego bricks or more complex shapes that then their team can reuse. So they're building those modules that you were talking about, almost like supporting them so that we know that every website is made up by a series of components that are like buttons and forms and header navigations. And so you can sometimes say, okay, I'm going to invest ahead of time in having a team that'll dictate what those reusable larger pieces are. And they'll dictate also a visual design language that not only looks like the brand and retains the colors that represent the brand or the system, but also work really well. Like the thing about the web, and in contrast to native mobile development, is that sometimes it feels like you're always starting from scratch, that you're always starting from an empty canvas, right? Like you start an HTML file and there's nothing there. And you've probably seen this, but like the default style sheet of a web browser is just downright gross. Like
and it's not consistent either.
The text flows from end to end of the screen, which I'm not an expert in typography, but like and typesetting, but like I know that people are not able to read comfortably if text flows from one edge of the screen to the other edge of the screen, right? So the web has always felt like this heavy lifting, in contrast with like Apple's design guidelines and their built-in component set. Where like they've spent decades thinking about what makes for a great user interface, and they give their developers kind of like a lot of pre-existing Lego bricks. The web, and I think for better, is a very flexible medium where you're free to publish anything and you're free to build it however you want. But in turn, what happens is teams and people tend to have to build their own component systems so that they have this kind of reusable layer, and that's how they scale their companies and their systems. And it's been a really nice trend to watch because at our company we've built our own design system, and we're putting in constraints in there that are very interesting. For example, for accessibility, like we make sure that our buttons react in certain ways to user input so that they're accessible to people on screen readers and things of that nature. And components can also make sure that they have the right font sizes so that the developer doesn't have to come up with they don't have to really decide that every time they build something from scratch. They're like, what is the right font size for this? What is the right amount of padding for this? So this has really all been enabled by React creating this idea of you are, as a front-end developer, your job is to define components. And by doing that, they kind of elevated the abstraction bar, because in the past, when you were programming with JavaScript and you were working on your front end, you had primitives that were, to put it lightly, too primitive. So if you were working with full stack legacy technology, you were working with templates. And then on the client side, you were working with functions or you were working with classes, and there was really no structure to how you were doing things. So React came in and were like, okay, what you're building is not a function per se, it's not a class, it's not a template, it's a component. And by doing that, they've really just revolutionized front-end development.
Yeah, I mean, I think and this might be different with HTML5. You could check me on this, but with at least with early HTML, you were limited to the tags that the browser
Correct.
provided. So there's a button tag, there was an input tag, a head tag, body tag, paragraph tag, but there isn't a calendar tag. Right. And so when you're writing your HTML, if you get to the point where you need to drop in, a little calendar, you have to use this tag called div. And then what you have to do later on is you give that div an ID, which says, my great calendar. And then later on in JavaScript, you would have to basically fill that div in with the logic behind that calendar, which is going to be composed of all of those tags that you do have access to. But then, that makes things really frustrating, because you end up with just a whole HTML file full of divs with different names. It'd be great if you could just have a calendar tag. And that's sure. Basically the premise behind React.
Yeah. And doing so, by the way, proved very challenging, right? Because what you were describing is a great kind of historical review of how websites used to be made. And you mentioned that word ID, right? And that's kind of how a developer would approach kind of giving life to an HTML tag. And even the very idea of an ID was very limiting in terms of the reusability of the Lego bricks, because an ID was pointing to a specific element. So from the get-go, you weren't designing something that was reusable. Like you couldn't clone your calendar and use it in different places of the system, and it wasn't parametric. So that's what I was saying, that components is such a great abstraction, because typically what would happen is like, okay, I have this div, and this div in particular that lives in this very page, I'm going to convert it into a calendar, and it's going to exist with fixed parameters. It's going to be this big, it's going to be this wide, it's going to be set, the default date is going to be today. But tomorrow, another developer was like, oh, hey, I need that calendar, but I need it more for selecting your age. And I need it for other years, and the default should be, 20 years ago. And then they would be like, oh, maybe the best thing I can do is copy paste here and fork the calendar into two calendars. And it was really messy. And it's crazy to think that, that was not that long ago, we're programming like that.
Yeah. That's right. Probably some people still program like that. So.
Yeah, and it's also not for, it's not really their fault, because as you were saying, the web emerged for hypermedia, and it was specifically a very narrow subset of what the authors of the web thought the medium was good for, right? So I always point people to kind of in terms of a historical review, when the web was being discussed in this open mailing list, and they were discussing the early, standards and emerging standards in the early web browsers, there was a lot of resistance to adding power to the web. And it was for a good reason, because there were all these interesting constraints that the designers of the web had for, how well the web should work. So one of the things I always point out is there was a very heated discussion about adding images to the web. And it's a discussion in which Mark Andreessen, the co-founder of Netscape, is involved. You can look it up today because it was a public mailing list. And you can see how there was resistance to adding, in that particular case, an extra hop to the information transfer process. Because when the web was created, you would request an HTML file from a remote server. And that contained the entirety of the information that you requested. And the constraints were there because obviously at the time we didn't have good, internet connections. So we're working with what we had. So like, you were sweating every hop, like, like it was the end of the world.
Yeah, I mean, everyone's seen this, where you get a little square with a red X instead of the image. And that's because it didn't come with the HTML.
Correct. So that's what I was saying. Like, I respect what they were trying to hold the ground and hold the line for like a level of coherence and correctness and performance to the system. But at the end of the day, the free market, so to speak, because Mark Andreessen was creating a new web browser, right? And he was coming from, and I could imagine him in Silicon Valley saying like, the web could be doing so much more. We could have images, we could have video, and in the future, people are going to be, telecommuting and like doing telemedicine, and like you could have all these dreams about the web, but the web was super constrained. So it was a slow process, but the web started getting more and more power and more capability. So that created the image tag. But as you were saying, the web goes through this process of adding things to standards. So as we stand today, we actually don't have a calendar tag. You know what I mean? Like it's been 30 years, and through sweat and tears, we added things like, image tag to HTML, but we still don't have a calendar. So, but if someone is listening today, they were like, oh, I just, filed my taxes online or whatever, and there was a calendar right there. So that's what you're dealing with, is basically the ability for the web to grow its own component set thanks to the help of JavaScript, which can sort of take all these primitive HTML tags like div and turn them into very interactive widgets.
Right. And in a way, the GitHub, with NPM and GitHub and the GitHub stars system, you can kind of get a standardization through democracy, right? So I mean, now what people do is they say ReactJS calendar site:/github.com. They punch that into Google. They find some calendar component that has 100,000 GitHub stars, and they grab that, and so does everybody else, and it creates sort of a nice sort of gnosis. Like people now have this sort of unconscious understanding of the calendar because they've seen the same similar calendar so many places.
Yeah, and this open system, right, I think takes longer. The open system makes it such that, we've been through generations of broken, inaccessible, subpar calendars, but there's always this constant iteration process aided by what you were saying, like all kinds of different scoring mechanism and popularity mechanisms, and, people just wanting to beat the horse that is not yet sufficiently dead in some ways. Yeah. Like I've seen so many times that like I consider a problem to be solved on the web, and then I see someone doing it better. Like they just make it smaller. They added an animation that, I didn't think of. They make it work better on mobile. Like the web is just this constantly iterating system. But for people that are getting started, it doesn't mean that they have to go through that. It doesn't mean that they have to build their own components. So you can always choose from libraries of components that other people have made. Like in the Next.js world, we know a lot of people use Material UI, which is like Google's component system that is open source, and it has been it's being distributed today as React components. There's another one called Ant Design that came out of Alibaba Cloud in China. Is very popular as well. So companies have also open sourced their entire component systems, which is really nice.
Yeah, that's awesome. Yeah, so maybe just we could talk a little bit about how React does this. How does React add components to HTML? I think that would be really interesting.
Yeah, that's super interesting, because one of the things that I always point out that React has been really revolutionary for is the programming model. So when React started, when the authors of React were kind of presenting it to the world, they were saying, look, React hasn't been so much inspired by previous JavaScript libraries like jQuery and so on. They were saying, like, listen, like this is an altogether new thing. And I think because of that kind of narrative, they were dismissed a little bit in the beginning because, a lot of people were telling like, sit down, this is completely different. And then you end up being disappointed, right? But in this case, it was true. So React wasn't so much inspired by previous, what we call imperative DOM manipulation libraries. So DOM is the basically the way that you interface typically between JavaScript with those HTML tags. They said it was more inspired by how game engines paint a screen. And this is really what also, in addition to the introduction of component, which is not altogether new, and there were all kinds of widgets and widget systems all over the place, including jQuery UI. But what was truly revolutionary was this idea that you're not really giving a specific instructions to the computer when the user does certain things. You're always saying to the computer, hey, for this state of the world, I want the entire screen to be like this. Almost like a mapping from data to screen in a way where the developer didn't have to think about the deltas. So for example, say that you're programming a clock, right? And you want the time to be rendered, I'm in San Francisco right now, in the time zone of San Francisco. The primitive value of the time, let's say, is a timestamp, and it's an integer. And then I want to say every second, I want to update the screen, and I want to render the time formatted to the time zone of the user, which is, I'm in San Francisco right now, and I want to decorate the clock in some way or another. When we used to program that with old technologies in the web, we used to have all this imperative code. So for example, we would say, okay, it's the beginning of time, so let's render the time for the first time. Then we would like put in that code. And then we would create a timer that says, hey, every second, take that and update it. So basically, there was this distinction in how you would program. There was this idea of time that was being embedded in like, okay, this is the beginning. We painted like this. Okay, now changes are coming. I have to go and look at the screen and make this a specific change. Whereas React came in and said, look, you're just going to describe what the screen looks like, and we'll handle all the updates to the screen for you. We'll handle, for example, if you register the time to change every n seconds, and we have to make a manipulation to the screen, we'll do all that. You just tell us for this particular data how you want the screen to look like and what components you want to involve in that.
Yeah, so it's kind of like there's something similar with the graphics world, the computer game world. Like for example, with OpenGL, if you just use pure OpenGL, you have to say, draw the triangle, wait a 60th of a second, draw the triangle, draw the triangle, draw the triangle. If the triangle moved, next time draw the triangle. But if you do something like Unity, you just say, I have a triangle and it's at x equals 3. And then you could wait a day or an hour or a minute, whatever, and then say, okay, now my triangle's at x equals 6. And Unity is responsible for just saying, draw the triangle. Or you're just saying how the world looks, and you let Unity, the game engine, handle drawing it. And Correct. So React is kind of that for the web.
Exactly. And the web, we were working on the web exactly like you were describing, with like almost like accessing the graphics card. We were working on such a low level that we were concerned with things that could be basically automated. I remember when React was getting really popular, a lot of people were comparing it to automatic garbage collection and going from manipulating memory manually to letting an engine do so automatically. And the metaphor is really good because the best example is like in modern, very complicated software programs, you're not just dealing with like moving the triangle from A to B. You're dealing with the user saying, well, now forget about it. I don't want a triangle. I want to go elsewhere. And you have to ditch the triangle. And you need to like get rid of it entirely from the screen. And if you think about the old world and how we used to program, we would use what we would call CSS selectors. And we say, hey, okay, the user wants to go somewhere else. So first, let's clean up the screen. And we'd like select the triangle dot remove. And we would literally write that code. We would invoke a function to handle these deltas of the screen's contents ourselves. So You could imagine how buggy programs were, because a developer that is working on like millions of different things sometimes forgets to handle these state transitions with manual code writing. So the declarative model of React it really was not only introducing this native idea of a component, but it was also this transition away from imperative programming to declarative programming, and just involving techniques from functional programming a lot more.
Yeah, it totally makes sense. Like in Excel, right? Excel, you set up sort of these equations, and then as your data changes, you don't have to go back and recompute anything. It's just kind of it's reactive, and so React.js is also reactive in that way.
Yeah, so, and a lot of there's been lots of debate about whether React is a truly reactive system in the formal definition of the technique. But the reality is that what you're saying is absolutely right. Like, the developer that works with React today is more concerned with manipulating data than describing, okay, for my screen should look like this for different versions of that data. And then they're not concerned with adapting the screen when the data changes. Much like you're saying with Excel, when you change a data point, you're not going and updating all of the data points that depend on that data point, right? You're not doing any of the manual calculations. That is, in fact, the true power of Excel. So React is kind of bringing this for front-end developers, which is really, really fascinating.
Yeah, totally makes sense.
Hey guys, we're going to take a little break to talk about University of California, Irvine's Division of Continuing Education. So this is a pretty cool program. They have a variety of different kind of certificates that you could acquire. They have things like Python, they have data science, they have machine learning. And these are things where, if you didn't necessarily get, let's say, a degree in machine learning, or you haven't worked as a machine learning engineer for a bunch of years, this is a way to sort of get a lot of that knowledge, a lot of that expertise. And I know Patrick and I, we've both done a bunch of courses online, and so it's a really good way to sort of boost your knowledge and your skills in a particular area.
Yeah, I mean, I did tons of online classes when I first started working, and for me, being part of a class, I mean, it's always interesting, but the curriculum, the self-paced stuff, it works great sometimes, but sometimes having here's what we're doing each week, marching through their curriculum and going through it, it's very similar to how just a normal university class works. In fact, feeling like it's almost exactly the same is just a comfortable thing, a good way to learn, and learning from professors who, that's their thing. They teach, they help others to learn, and having access to it, doing the assignments. It really helped me go from, where my undergraduate left off to just kind of bootstrapping into more specifics, higher level things, things that were more pertinent to my job at the time. I highly recommend people taking classes, continuing education from a college.
Yep. Yeah, I think getting it through a university is actually really, really stellar. I mean, it's really awesome that universities are starting to get into this. And that there's going to be sort of quality lectures and professors. There's a very strong brand behind any sort of major university, and usually Irvine's one of the top universities for CS. So they've been around since about 1962, I think, and they've been around a long time. They've been teaching a long time. They've been teaching online a long time. And so it's a good place to go and get this kind of education.
Yeah, if you're interested, I think they're still doing enrollment for some late classes for spring, but summer's upcoming. And as we've been talking about this whole episode, I mean, I think everyone has extra time at home these days.
Oh my gosh! Yeah.
If you're interested, you can check it out at ce.uci.edu/programming throwdown. And we'll put the link in the show notes, of course. But once again, that's ce.uci.edu/programming throwdown.
Yeah, and if you do sign up and take any courses, we'd love to get feedback. Please write us in, tell us what you think of it. We could pass it on to them, but also for us, it's really good to know, what you thought about that. Folks out there who are listening. So, all right, back to the show.
The thing about React that might be a little tough for folks is there's the JSX. Like there's like the way you sort of mix the HTML and the JavaScript. I know that throws a lot of folks off. But nowadays, with the really nice IDE support, that makes that whole process a lot easier. I mean, you get the right syntax highlighting, and the IDE will tell you right away if you do something wrong. And so I think combining ReactJS, for new folks, combining ReactJS with a good IDE and a good development system is really important.
Yeah, and this is kind of why we invented Next.js too, right? So React started as a mechanism for kind of being able to capture the emerging and kind of relentless complexity that was growing within Facebook's code base. There were classes of bugs, categories of bugs that kept happening that were frustrating the developers. They were saying I think one of the interesting things that I've learned about software engineering is that the appreciation for categories of problems rather than problems as independent, unique things really makes a world of difference, right? Like you don't want to spend your time fixing like things, novel little things that come up. You try to say, okay, this belongs in this category of problem. Let's try to find ways that we can fix the category rather than patch each issue as it happens.
Yep.
Fixing the root cause, right? And there were categories of issues that were happening within Facebook that are very much related to what I was sharing earlier. Like, hey, I'll give you an example also with the clock. Cleaning up stuff when something that was on the screen is not there anymore was always a challenge for web developers. For example, the clock has to repaint every second so that we can like make the obviously the time change, but we can make, I don't know, the colon flicker so that we have a nice animation for our clock. What happens when you navigate away or you just go to another portion of the system where that clock is not there anymore? So a category of problem that would happen a lot was like the developer would correctly remove the clock from the screen, because that's a very obvious visual bug, right? Like if you went to another portion of the system and there's a clock lingering there that you didn't want, but what they would forget is to clear the timer that was trying to every second clean up update the clock and do an animation and whatever. So the interesting thing about this is that it would be completely silent. That timer would be running in the background because of an implementation detail in jQuery, which is a library that people were using a lot at the time, which when you would select an element that was no longer on the screen, it would just swallow the error. So basically, if no HTML element matched your selector, in this case, the clock was not there, and you were trying to like do something like update it or whatever, jQuery would just say like, oh, it's all okay. And then you would have all this load accumulating in the background that is completely invisible to both developer and user. So this is really bad, especially at the scale of Facebook, where like people spend a lot of time on like navigating their news feed, or there's lots of things that are constantly updating, right? Like you've seen how likes update in real time. You've seen how comments update in real time. Now they incorporated that your friend is typing in a newsfeed post. There's video, there's polls, and everything auto updates. So imagine managing all that complexity manually, all those timers, all those subscriptions to real-time updates from the server. It was resembling a very complex video game, really, with like lots of characters animating on the screen and things like that. So when they were, they needed to solve these categories of problems, they created React. But what we noticed, and this goes to your point about usability and IDEs and making things easy, is that people needed a very easy way of using React for everything. So Facebook at the time was concerned with incrementally adopting their own invention and solving, the most pressing problems. Like, if I remember correctly, I've heard from their team that, the notification center was something that they wanted to fix immediately with React. The chat windows that kind of hover over your screen is something they wanted to fix with React. Like more of the challenging pieces of the UI that, again, deal with lots of data updates. So as of this morning, I was reading on Twitter, like people were annoyed that for whatever reason, a bug on the system, like the notification count is not updating correctly. So those are kind of the pressing things that Facebook was solving with React at the time. But what we noticed is, hey, this model that React is using that Facebook is using for very specific components, what if we could use that to build the entirety of a website or the entirety of a web application? What if React is your starting point and React really kind of becomes your language, so that you don't have to relearn all these, painful practices of HTML and jQuery and like imperative programming? What if you could just start your project and everything's already configured for you? React is configured, all the production optimizations are, figured out for you. The compilation pipeline is figured out for you. And all you say is, hey, I want to start a new Next.js project. And this is kind of how Next.js was born. In fact, the need that I had when, like, React was already open source and it was already getting a lot of traction, but I needed to build one page with one form for a company to receive emails. And I was like, it's very hard to assemble all the pieces. Like, React is awesome, but starting from scratch is so difficult that it felt like you were, configuring a compiler and writing a make file.
Yeah, just to give like some insight into this, like so yeah, the React is, you don't like in React you can have a calendar tag, right? But HTML, as we talked about, that tag doesn't exist. So what React has to do is it has to turn all of these tags that you invented into their basic components, and it does that by basically compiling a lot of these files down into essentially another language or some generated code that's not human readable. And that process is pretty expensive. It takes time to do all of that. There's challenges around like hot reloading. Ideally, you want to change a component and see the result right away, or at least you don't want to have to compile every file. Yeah. There's just so much complexity there. And there's like Create React App, which is a wrapper project that gives you kind of an initial React app with a lot of the bells and whistles, but even that then is now complicated, and so you have to deal with like proxies and a whole bunch of other things there. And so
what you're saying, it really goes to the heart of the problem, right? Like, the reality is that React is not a native thing of the web. Again, going back to like how the web was created and like how it was evolved and the standard systems that are around it. React is like a foreign body in all this, right? Like, it was something that a company invented. It was made open source, and it interoperates with the primitives of the system. The primitives of the system are HTML, JS, and CSS. So something that Next.js does, for example, is really interesting. I was giving the example of the blog. So if you're designing your blog, you're thinking about it in terms of components. And we use this JSX language that allows you to refer to components as if they were HTML-looking tags inside your code. So when you're designing your blog, you define a function called blog, and you say return, and you include the header tag, and you include the blog post tag, which are all these components, and then you include the heading component and the text component, and then the footer component, and then the contact form component. So, and you return that. And it's really nice because if you think in terms of math, you're writing these functions that have a discrete input and a discrete output. It's a beautiful thing. So like you're basically just returning components from a function body. But what happens is, again, the web, it speaks a different language. It doesn't speak components. It doesn't speak JSX. It doesn't even speak the new versions of these languages that people want to use. So that's where the compilation step comes in. So an interesting thing that Next.js does is that for the first impression of your website, we compile it down to HTML and CSS so that it's super, super fast. In fact, no JavaScript has to get loaded for your visitors to get, again, primitives of the web, HTML and CSS, that you didn't write by hand because you were speaking the language of components and you were having a very nice and easy time creating your system. But again, we have to interoperate with the web that has, billions of devices, all at different versions and browsers and so on. So that's where Next.js is kind of like hiding all this complexity from you. And it's quite, interesting. What we call this developer experience, right? Like this is kind of the term that emerged. We used to speak only of user experience, UX. And then at one point, this word started getting traction called DX, right? Developer experience. Because again, like doing all this juggling of what the developer wants the experience to be, but then on the other side, we have this kind of, I'm not going to call it legacy system, but we have this very basic system that is at different versions because of different web browsers. And we needed to build that glue to kind of make those two worlds compatible.
Yeah, that makes sense. So can you like explain to me a little bit what does Next.js build on top of ReactJS? So in both cases, you have JSX, which is not something the browser can understand. So we compile it down to, at least in ReactJS, we compile it down to HTML that's being generated by JavaScript functions. So you have this JSX file. It has a lot of these HTML tags that don't exist in the browser, and so the compilation step, runs that basically like runs through that file, looks at those tags, and then kind of recursively goes through and replaces them all with the right thing with something the browser can understand. And so, what does Next.js build on top of that?
Yeah, so one of the biggest things that Next.js became very, very popular for that, for example, Create React App doesn't do, and this is not because Create React App existed and we're like, oh, we're going to fix it, but they both kind of came out at the same time, is pre-rendering. So this is one of the pieces of Next.js where most of the investment went into, and it's why it's been chosen for many, many large websites and web properties that receive lots of traffic. So pre-rendering means, as you mentioned, there's all this JavaScript that has components, that has JSX and so on, but we already know what the data is. Why are we not giving the visitor the HTML with the data already in there instead of an empty page with a lot of JavaScript that then has to make an HTTP call to an API or whatever? Again, like that's why I mentioned this single hop principle of the web, right? Like we host lots of news websites, for example, right? And when the visitor comes, there's kind of two worlds here. Like one world is you give them an empty page, like no HTML, only like a root element, and you give them a big bundle of JavaScript that then when it boots up on the user's machine, and if you've used the web a lot, you probably see this sometimes, that you get an empty page and then a long time passes and then some content magically appears. So we wanted to prevent that because there's large categories of pages on the internet that, they don't need that extra hop. So Next.js became very, very popular because of this pre-rendering technology. And so that's kind of one, you were asking at the compilation.
Yeah, that makes
one
sense.
Technology is underneath. The other is that, again, we don't want to make the web dumb. We want to make it very powerful. And this is even, what React is really good at. So what we do is we can take the pre-rendered markup and then we hydrate it on the client side. And then you can kind of bring in endless interactivity to the website. That's why, like kind of something that I kind of became a hill that I've chosen to die on for many years now is that I don't really see a distinction between a website and a web app. It really is just a matter of the developer deciding how much of the content is pre-rendered or not. You might find that some websites only pre-render very little because the content is so naturally dynamic, right? So like if you're building a multiplayer chess website, well, when you first load it, there might not be that much to pre-render because, again, like there's a lot of animation and interaction and the data, maybe it's stored on even the local device rather than on the cloud. And there's all this needs for very dynamic client-side rendering and hydration. But if you're building a news website and something recently that happened is that, we noticed that when governments were kind of, rushing to get stuff out about coronavirus, they would put it on systems that would immediately collapse under load, that would be slow, or they were taking too long to get the information out. And this is why for us, pre-rendering has been such an important feature, because if you're going to tell somebody, what the 3-phase plan is for, releasing the lockdown in the US, you're better off putting out a pre-rendered page that is primarily HTML and CSS, that scales tremendously well with huge spikes of traffic. And it kind of becomes your, using the web as a printing press, I call it, right? Like you pre-rendered a page, and that pre-rendered page becomes infinitely scalable. It's like a magical pen that you could distribute across the world. But the magic.
So if I could sort of just recap for folks in the audience. So the idea is, originally you had HTML and you had JavaScript, and they were in separate files. So someone would go and download the HTML file. It would have, and as we talked about earlier, the images were in separate files. So you'd get the HTML file that would have, none of the images and no logic, but it would have a lot of structure, and it would have all the text, and it would have the structure, the layout of the page. You would download the JavaScript then next, and it would have logic that could then go to a server and pull some extra information, or not. You don't even need a JavaScript to have a website, and it would pull all the images, right? So then when you switch to React, what you end up with for most people is the HTML page is effectively empty. And all of the React components end up turning into JavaScript functions. So you download this empty HTML file, you download this enormous JavaScript file, and then you kind of call go on this JavaScript function file, which then recurses, creates a bunch of functions, or launches a bunch of functions. All of those create this massive string of HTML, and then that ends up replacing the empty HTML. And that's how you can have things like a calendar tag, which don't exist, right? And so what you're saying here, Guillermo, is that with Next.js, just to finish the React thing, and then because these websites are sort of living, breathing things, you also have an update function. So every component has your sort of render function, and then you have the ability to sort of call that again. So it's kind of on you to say, hey, go fetch some data from the network and then call render again on this component.
Yeah, I'll even say that the calling the render, this is what's fascinating. The calling the render for all the parts of the screen that could have possibly changed is done by React, right? So like going back to your great Excel metaphor, your job as a developer is just mostly to alter the data, as you said, with networking API calls, even sometimes like reading or writing from the local device. But then React just like says, oh, I'm going to repaint. I know what parts of the screen need to get repainted. I'm going to repaint them, right? So there's very little work for you to do in terms of re-rendering things, which is it's a huge time saver.
Yeah, but you still have to. You're still responsible for basically using some kind of. You could use a observable type thing, but you're responsible for going out. If you're let's say if you're doing the chess example, you're responsible for going to the server saying, hey, has the other person played yet?
Correct.
The server comes back and says, yes, they have. And then you have to update that, somewhere, whether you sort of, however you do that is up to you, but you have to go and update that.
That's basically. So when we talk about React, especially for those that are going to go deeper into it, we say a component has a state and it has a render function. And the render function returns HTML as a function of that state. So it's almost like a bijective function of, hey, here is state. It has the properties of the board, where are all the pieces, and then we return a bunch of components for like the chess pieces and so on, and React does all the heavy lifting.
Yeah, and so for some of these components, the state might change very often, right? But for some of them, maybe the state, going to your calendar example, maybe the state just holds the day you want it to start the calendar on, And so for that reason, the state isn't changing all the time. It might change if someone picks a day, but let's put that aside for now. It's not changing every minute or anything. And so in terms of actually the majority of your components probably change very little or none at all. And so what Next.js does is it says, let's look at the initial state of all these components. Let's call that big function that generates that huge bunch of HTML, and let's send that instead of the empty HTML. And then if there are changes, we'll handle them. But at least that very first thing, which is really expensive, we could do that on our side so that each browser doesn't have to do it.
Yeah, that's exactly how it works. And so to give you context on this transition, we went from the web just being HTML that was like non-interactive at all, and that was all coming in one hop. And as this kind of rich JS applications with components were kind of growing and rising, we kind of we overcorrected it the other way. And this is kind of the story of how progress is made, because then we had to bring it back to the middle with Next.js a little bit, right? Because we went from, now you go to a website and you get nothing in that initial response. You just get lots of JS that your phone or your computer has to boot up the JavaScript virtual machine, interpret it, compile it, optimize it, parse it, and then it spit back out some HTML, which is really, we're talking about that OpenGL triangle. That is how the information will actually come to your brain eventually, right? The way that, data is transformed into pixels on the screen today is that fundamental HTML or DOM, data structure. So we were adding latency, and we were adding, as you said, megabytes of JS that had to be downloaded before doing anything at all. So Next.js was like, okay, that cannot be the only way. That's one good way for certain things, but that cannot be the only way to build things. So Next.js added this idea that, hey, you have all these components and all this rich JavaScript. How about we also try to pre-render it so that the user can get content and data right away? And this actually made React just way more broadly accessible and more broadly applicable to things where, you would dismiss it sometimes. You would say, oh, no, I cannot build a, landing page with that. I cannot build a coronavirus, instructions page with that. I cannot build a blog. I cannot build a news website. I cannot build all kinds of systems. And going back to the hill that I die on is that I don't think any system has ever fell in one direction or the other, right? Like, you could have the most dynamic system in the world, but I can assure you that there are pages that are fundamentally somewhat static, and you could have pre-rendered markup for. I remember the first experience that I had with this thing was like I was building a very dynamic system with React, and then I had the terms of service of my system as a separate file, right? And this was all written with components because that's how I wanted to build the world. I wanted to use these Lego blocks. So I built the terms of service with React. And then the naive compiler that we had at the time was shipping the terms of service together with the rest of my application in one gigantic JS bundle anytime the user wanted to do anything at all. And as you know, a lot of visitors of the internet don't ever even go to the terms of service, unfortunately, right? But that's what happened, right? So like we were so naive with how we would bundle things that we ended up with this gigantic just like apps that were getting downloaded. And for a time, we kind of mitigated that with CDNs and whatnot. But then we started realizing, like, why are we shipping all this code that the user is not even interested in going to yet, right? So another feature that Next.js added that was quite interesting was what we call prefetching. So we have pre-rendering, and then we also have prefetching. So for people that are used to visiting very dynamic JavaScript apps or single-page apps, as people call them sometimes, you know that the transitions are super snappy. And that really feels awesome. So you touch something, and then you immediately go to it. Like, there's no delay. There's no perception that you're going to a remote server or anything like that. So as it happens, we wanted to retain that property for our system as well. So what we came up with is this idea that, hey, there's this component called link that we give you. This component you don't have to build yourself. And when you use link, to link pages together, we can start prefetching the next page before the user has even thought about going there. So what you end up with is a system that merges pre-rendering with prefetching. So you kind of have your cake and eat it too. So the system feels super snappy. You get data or you get a shape or you get content in the first response, and you still retain all this goodness of the web. You retain hyperlinks, you retain bookmarking, you retain back and forth navigation, and yet things can be infinitely complex once the pages get hydrated. So that's what I was saying, like, you can build anything you want with React. You can build a chess game, you can build a blog, you can really build anything. It's quite the interesting technology to learn.
That's awesome. So the idea is, like, if you have your terms of service behind some settings page,
correct,
then if someone hasn't gone to the settings page yet, you don't really need to even bother loading the terms of service. When they go to the settings page, as soon as they get there, before they even click terms of service, then you can say, okay, let's load it, so that at least if they are going to click that, it happens instantly.
Yeah, and you know what's fascinating about this is that we use information about the viewport to prioritize what to prefetch. And we also make sure that we're not getting in the way of other important information being loaded. So we use an intelligent prioritization system. First of all, we prioritize prefetching what's visible on the screen. But secondly, we don't prioritize it so much that it's getting in the way of loading the chessboard, right? Or whatever it is that that particular page that you were developing was concerned with rendering. So we actually have spent lots and lots of engineering in this intelligent prefetching system. We're really happy with where it is today, but there is so much more still that we can do. So something that we're researching currently is we can know, based on the trajectory of your input device, right, where you're likely to go next, right? And we know this from several sources. One is the motion of the pointer itself, right? Like, the pointer is pointing to a certain link, we can start prefetching that. The other one is on mobile, determining the motion, right? Like, the user might be blindly scrolling, or they're stopping and looking at something. And in a lot of cases, what we do is we start prefetching when you first begin the tap action rather than when the tap gets released, and so on. And then we can use information about your traffic as well. So there is a integration for Next.js called Guess.js that uses information from Google Analytics to know what to prefetch and to prioritize prefetching. So it's quite fascinating, right? Because the only thing that you think about as a developer, and you get all these benefits, it's just linking between pages. And I shall say also that that's the other kind of important primitive that Next.js added to the React universe that it was, in my opinion, sorely needed, which is the page. So in the Next.js universe, you don't have just components. You define what pages you're building first. And all those pages themselves are just React components as well. The top level thing is a component, and then there's deeper components. But the fact that there is a page as a concept allows you to, like I said, retain all these very cool properties of the web, but also powers this intelligent prefetching system.
Yeah, that's awesome. Yeah, that makes a ton of sense. So you were talking about things that you're kind of looking forward to and things you're working on. So what is it kind of like to work at Vercel? Like, how many folks work there, and what's that environment like?
Yeah, so funny enough, before this coronavirus pandemic happened, we had just organized an online event for basically front-end developers. We called it Backendless Conf, because the mission of our company is to empower front-end developers and allow them to bring their websites online and web applications online with ease. And for companies to also have the opportunity to reinvent their front ends, because we notice a lot of companies kind of neglected investing in the front end. And I always say, front end is where your visitors are, front end is where your customers are. So we started Vercel as a way of, tailoring and targeting and helping this front end experience problem. But before, even before the pandemic happened, we were already organizing online events like back in ListConf, because what we'd noticed is, our product was already starting to enable people to work in ways that were very distributed, right? Like you didn't have to be in an office to build components, to deploy them and get a URL and share them with your teammates. So our product was already kind of like headed into this world of like, hey, like if you have great structure, if you have a great way of dividing up the work in the world, it kind of makes sense that you should be able to do that work from wherever you are, right? So as a company from the get-go, we're very remote friendly. So even though the headquarters are in San Francisco, we always figured, hey, the purpose of these technologies is to allow people to kind of be freed from the constraints of the physical world to begin with. After all, we are publishing to online media, right? So Vercel was always a company that had this as a kind of guiding principle, and
that makes sense. It's one of the great ironies, right, of Silicon Valley that sort of the people who invented, or at least I guess the country that invented video conferencing, I think it was invented in New York, but it's sort of like, then it's like everyone's sitting in a giant bullpen, right? It's like, couldn't even dog food that invention.
Yeah, it's fascinating. I think it's part of a transition. I think it's part of an acceleration. A lot of people, say, well, we're about to enter a recession and things are going to get really bad. But I honestly see it as the opposite. I see it as we're about to enter the dawn of a lot of things that we're doing in ways that were quite paradoxical, I think. When it comes to work, I think it was a paradox. Like we were building tools for remote work, but the builders of the tools were not embracing remote work. And I think that goes also for like publishing, right? Like we're this is a problem that we're really attacking face on with Vercel, is we were publishing our front ends to one location in the world. Like you mentioned AWS earlier, like the way that people use AWS by default, and this is the default region, right? They create a server in Virginia. It's the US East location. But we're publishing globally. You're selling globally. You're speaking to global audiences. Why are you putting everything in one server, right? So Vercel gives developers this workflow where they publish to our edge network, which is located in dozens of cities around the world. So when you publish your pages, when you publish your content, there's no way to deploy just to Virginia. This is a new normal, is you deploy your front end to an edge network. So in some ways, like you could argue, oh, we're, a little bit ahead of the curve and whatever. But I think what's going to happen is that with this new world, people are going to realize these things that were already problems that were pre-existing to our systems. And now those solutions will see an acceleration in adoption because we need them. And we needed them before this even happened.
Yeah, when I look at, when I hear reasons as to why things can't be decentralized, it always comes down to things like, we'll have to document our code more. Like we'll have to have contracts between the teams, like software contracts between the teams. And I'm just sitting there like, okay, that sounds amazing. And it's like, and they're like, no, we'll need an extra, let's say 10% more people, to do all of these things, to have all this awesome documentation. It's like, yeah, I mean, that sounds like an amazing trade-off. And in exchange, those people can be anywhere they want. I mean, it sounds like a no-brainer.
One of my favorite essays online that I come back to a lot is this interview to a researcher out of MIT who works on what he calls digital reality. And the field of his research is to try to understand what exactly is the distinction between an atom and a bit, and what are the technologies that facilitate the conversion from the bit to the atom, right? And the most obvious one is 3D printer, right? Like you have content that is purely software defined, and then you can convert it into reality. And one of the things that he talks about, and he talks about Lego pieces as well, is that the geometry of the pieces is what enables the system to get complex. And he talks about how, you've probably seen this with like how we can birth human beings that end up being larger than the human being that they were born from, right? Like there's this incredible complexity that yields from very basic pieces. As long as these pieces can fit with one another, we can build really complex, interesting things. And John Conway died recently, and his idea of game of life is very similar from very simple rules, very interesting complexity can emerge. And I think the way that I see this play out in the software engineering world is that we sometimes have ignored the geometry of the pieces, and we have built things that are just so incompatible with one another. And React made this gigantic contribution saying, hey, the building block is the component, and now you can fit the pieces together really well. And now that means that we can build complexity in ways that are actually good, right? Like we don't want to build complexity to make the world worse, but now you can manage that complexity, and you started from one little component and you can grow out of that into a very interesting machine. And going to your comment about comments in software engineering, I think our job really is to always be defining these nice contracts so that, we make certain classes of problems completely irrelevant or invalid. Version control has helped us go in that direction, but I think we're going to see, that become even more and more rigorous over time. Like, today when you push a commit to Git, in a lot of cases, it contains no validation whatsoever, and like the system treats everything as just dumb text. But as we evolve our systems, we start getting better understanding of like what should be accepted or should be rejected altogether. And honestly, I hope that us defining collectively these better interfaces will I think it'll make work a lot more pleasant, so that we can focus on the creative sides of software engineering rather than like the bugs and all that boring stuff.
Yeah, I mean, a good example of this is code style, right? I mean, people would just fight and argue about code style, and then finally we got editor config, and we got the prettier. That's right. I forgot the C++. Oh yeah, Clang format. But basically, we got these machines and these rules that do it for us, and now, as you said, we can focus on. We don't have to spend time arguing about tabs and spaces. We can focus on more important things.
You mentioned something really interesting. You mentioned hot module replacement earlier. Mm-hmm. And I really think that React has also helped popularize, hot module replacement. So for those that are not familiar, as you're editing your code and you save it, you automatically see the change in real time with no interaction, with no refresh button on the screen. And this has been really the interesting thing about React, is that because it defined this incredible geometry, lots of other trends emerged together with it. So hot module replacement, you could argue, could have always been possible. But why did it become a thing that React became known for? Well, because the encapsulation of components and state and like the ability to cheaply repaint, like all that led to, okay, this new amazing capability is now, we take it for granted because, for example, Next.js automatically configures and gives you hot module replacement. But again, like you go back, 30 years, 10 years, 5 years, or even you go and look at how you mentioned desktop applications, how people develop desktop applications. And sometimes they wait, 5 minutes from a change to compiling it, to running it, to seeing, what the result of their change is. So just imagine what that has done for creativity and just productivity and just ease of use and onboarding developers. I'm noticing this fascinating thing on Twitter. It's called hashtag 100 days of code, where people are every day, doing one challenge a day. And I notice how fast newcomers to the industry are picking up React. And it's just really motivating for me to see, that we can be a part of helping that movement come alive, which is, you mentioned something interesting as well. It's like people switching professions, which I always see as an opportunity to also bring fresh new ideas to our field. I think that idea that you can go back and forth from, an expertise that you already had to a new expertise or a new medium for publishing is absolutely fascinating. We've been, with Vercel, we've been sponsoring researchers of coronavirus, of immunology, of virology, And we had the really great opportunity to sponsor a team. I believe it was out of Switzerland, of very renowned researchers. And something that really stood out to me was that they were all proficient in React and Next.js, even though that's not their thing. They were using the technology to create these interactive models with drag and drop sliders. I'm sure that the idea that they change the data and then the screen reacts automatically made lots of sense to them, and it was easy to grok. And then they only had one person in the team that was more of a traditionally trained software engineer, but everybody was contributing to this project. So this is kind of what we're still in the early innings of seeing this impact that React is having in the world. But I think it's going to be cross-disciplinary. I think it's going to help novices and professionals alike. We still work with lots of customers that have spaghetti PHP and JS code, all intermingled with lots of the categories of bugs that React has eliminated. But they're still making lots and lots of money, and they have very successful businesses, but they still are looking for that opportunity to reinvent their front end. So it really has been a revolution kind of across all fields and all levels of expertise.
Yeah, it's amazing. I do think that we'll sort of, a lot of these things will kind of democratize as we have been. I think on my side, I do a lot more on the machine learning and AI side, and PyTorch and TensorFlow, and these technologies have done the same thing, where you see there's a person who made people are making art with neural networks, and they're people who artists and people who don't have a background in software are able to participate. It's not just kind of for wizards anymore, which is, I think you're going to see, as you said, this sort of Cambrian explosion of ideas as all these people from around the world can kind of express themselves, right, using this new tech.
Yeah, absolutely. I'm really excited because it's the programming model for me that was really the game changer. I remember when I got into React, I didn't actually use React. I wrote my own React because I really wanted to understand
that makes sense.
What's going on here. And it just blew me away that, this is a new way of thinking, really. This is a new way to program, not just, a JS library. And so much so that, Swift UI, the new library that Apple put out for native UI programming, is very much inspired by React. And we're seeing, this inspiration of React just, go everywhere. And that's because of the programming model, not because, Facebook developers wrote very good code, which they did, but it goes beyond the code. And that's really, really interesting to me.
Yeah, that makes sense. So Vercel, the company, are you folks hiring? Do you have internships? Is there any stake?
We are, and we're specifically also hiring for interns. We basically run permanent internship programs. When we always have our application process open to anybody that wants to get deep into this front-end world. There's two classes of problems that we invest in. One is, what is the right cloud infrastructure for a modern front-end? So like I mentioned, an edge network, global delivery mechanisms of infrastructure, minimizing latency, minimizing the friction between the page and the visitor. So that's one category. The other category is we work on Next.js itself. We work on our own dashboards and ways of sharing the information about the projects that you have, the pages that you've built, and so you can basically contribute to our company in those two main areas, both infrastructure and purely front-end code. Right now, we're attacking some really interesting issues with Next.js that have to do with scaling to very, very large projects. So projects we're talking with millions of pages or tens of millions of pages. And one thing that I love about our internship program is we've seen people that came in as interns that are now our full-time, senior software engineers. And we kind of help them throughout that entire transition. So in addition to that, we're hiring for security, dev role. Basically, you can go to vercel.com/jobs and get the full list. But we'd love to stay in touch with everybody that kind of listened to us today. Also on Twitter. My handle is RouchG. And also for anybody that's interested in Next.js and learning React or starting to like build something useful with React, we recommend nextjs.org/learn, which is basically it's a step-by-step tutorial on building something with React from scratch.
Cool. So I think folks are interested. Step one, I would say go to nextjs.org/learn so that this is not to go on too much of a tangent, but I saw something recently where someone applied to a job, and I felt like they were a pretty good software engineer, but they actually kind of knew nothing about the company or like anything kind of like anything that they were sort of getting into, and so you don't want to be that person. So check out.
I think that's a really good point. Not only because it just helps your chances in a very objective sense. It's like I think it allows you, and this is kind of like a byproduct of this new open source world, is you can get to know the people that you would be working with and the problems that they're working on prior to making any kind of commitment, right?
Yeah, that's right. Yeah, totally right. You can see kind of, I think a really good side of people is when you have sort of design arguments. That's actually a side of people where you get to see kind of the real metal, right? And what that give and take is like and everything. Yeah. And all of that is out there in the public. I have a bunch of open source repos, and what people tell me from reading, people have told me feedback. They say I'm very short when I talk online. So that is something that maybe I'll work on, maybe I won't. I don't know. But no, you could see what the folks are like, which is awesome, and learn more about Next.js. And then if you're folks out there in college or high school, and you're interested in doing an internship, definitely reach out.
For sure.
Nextjs.org/jobs. Is that correct?
No, nextjs.org/ well, you'll find your way if you just go to nextjs.org. You can go to the Vercel website by clicking on the top, or
I
you
see.
can go to vercel.com.
Got it. Okay, cool. Great. Yeah, this is really, really awesome. I knew sort of very vaguely what ReactJS was all about. But now I knew vaguely about React.js, but now I kind of have a deeper understanding of what it's all about. And I actually have a project that I'm doing that I'm live streaming on Twitch, where I'm just building basically a simple website. And I think we're going to start it with Next.js. So
great choice.
I actually was going to start last week, and then I had some family stuff, so I'm gonna be starting it this week. And folks out there, I don't know if the episode will be out by next week, but we'll try this with Next.js. And so personally, I'm looking forward to trying this out.
Awesome.
So thank you so much for the time. I really appreciate it, and I know the folks out there are gonna love it.
Thank you.
Cool. And for everyone out there, thank you again for all of your support and all of the feedback. We've been getting a lot of emails, which is awesome. There's actually some emails from people who are kind of first, second connections to programming language inventors and all of that, which is awesome. In general, thank you so much for the support. Hope everyone out there is being safe, and you're kind of taking this as a time to do some kind of fun side projects and have time, at home. Catch you later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.